Welcome.
Hey, everybody. Thank you for joining us again tonight for episode 8 of our AV Tech Talks episode, podcast, webinar, however you want to put it. But thank you for joining us. Thank you for being here. Share the stream out. Get as many people as you can in here. We got some great information coming down today that a lot of people are really going to want to be interested in. It's going to help you fix those little tweaks and tacks that you have going on in your event setups, basically. So, of course, we have a few things to go over before we start. We are AV Educate. You're only as good as the crew that you have. I know it says episode 7, but it is episode 8. Don't let the slide lie to you. Obviously, thank you for Omar Colom, the creator and founder of AV Educate, for putting us all together and giving us the opportunity to teach you guys anything that we can possibly get. My name is Chris Brown, Bodie, IT guy. I've done just about everything that you can think of with computers. I'm resident streamer here on Facebook. We do have the brains behind the operation, which is Ed Wallach. He is an AV1v1 LED projection guy, all kinds of sorts of great stuff. He's going to be doing audio tech talk next week, so you don't want to miss that. Actually, not next week, 2 weeks. Sorry, I apologize. 2 weeks from now, getting a little ahead of myself there. We do have some house rules, guys, that we want to attend to. We go live on Facebook every Monday at 7 p.m. right here on AV Educate page. Get as much of the information as we can out to you guys. Any questions, do not hesitate to ask. We do this in a Zoom fashion. So there is a number that Ed will be putting in the chat for you guys to join us if you want to join us. But we are live here, so you don't always have to be part of the panel. If you want to, we encourage it. We love it. Bring it on. Due to the nature of streaming, as everybody knows, there is a little bit of a lapse in delay. It's typically about 25 to 30 seconds on Facebook between the time you ask a question and we actually see it. So if you give us a minute, we will get to your questions, and we're kind of going to do a round table. So it's going to be producer, producing and getting the information to you, and then looking at the questions, compiling them, and then getting back to you. We want to do everything we can to get you as much information as we can. So if you find something that worked for you and we're not saying it, share it in the chat. We have no problem with that. We don't know everything. So this is a learning experience for all of us to get through. Tonight, we are going to be doing data networks for production, fundamentals, tips, and traps. And our presenter tonight is going to be Justin Herminghouse. I hope I said that correctly. I hope I didn't butcher your name. We're primarily focusing on audio streaming and lighting and other areas of today's industry. Everything kind of goes over IP networking and things like that. So Justin's going to fill us in on how to fix your problems and not look like an IT bum on site. Take it over, Ed.
Great. Thanks, Chris. So yeah, I invited Justin here. I think this is going to be a great topic. I think a lot of people get very, what's the word? I guess there's a lot of confusion about production IT. There's all sorts of levels of it, and it's something that can trip you up. So hopefully Justin's going to be able to demystify some of that for us. If you have any questions on the Facebook side, please post them in the comments. We'll take those questions live. And Omar, do you got anything before we just let Justin have at it?
I do not. You guys killed it. You guys did a great intro. Thank you so much for that, Chris. Thank you for that, Bodie. Justin, please, man, take over. You don't want to hear me talk. I got nothing to say.
Well, so you got me. Great. Pleasure to be here tonight. So basically what we're going to we're going to go over presentation, a bunch of the fundamentals, what the network is, how it works, some of the physical media, some of the basic concepts and addressing and such. We'll work our way up, and then we're going to switch to a panel. So, and by the way, if you came for the, improve your PowerPoint presentation, etc., you're at the wrong seminar. Anyhow, with that, I'm going to start with 2 words nobody wants to hear, but this is going to be worth it, and that's conceptual models. So when we talk about networking, and it's not just data networking, this happens everywhere else, there's a model called the Open Systems Interconnect model that divides it up into 7 layers. It's not just that the data comes from your application, goes somewhere else. The best way I've heard this described is to think of it as nesting. If you've ever seen those nesting dolls where you put one inside the other, that's sort of how your data moves up and down the layer. So Ed might hand me a package of information. I put inside another one and then say, here, let's give this to Omar. I don't need to know what's in it. I just need to get it safely where it's going.
So that's
So-
not the same as the 7 layers that Taco Bell used to talk about.
No, and I was going to do the joke about there may be drugs in
Food?
the egg, but so this is a fairly simple model. There are some holes we may or may not want to get into with sublayers, but working from the bottom up, the bottom 3 layers, the physical, the data link, and the network layer, this is basically when we're talking about moving data on the network, what we're talking about. The top 4 layers, transport, session, presentation, and application, are really what happens at the host machine or computer. And it doesn't just, we can translate it. We can apply this model to things like in audio, AES digital and SPDIF. At the physical layer, layer 1, they're very different. They use different voltages, different impedances, different connections. But once you get up into higher layers, how they're framed, how they transport audio, what codecs they use, you can actually shove AES digital into SPDIF if you account for the physical differences. So it does translate. So when we're talking about networking, we have the physical layer, first of all. What's the ones and zeros? How does it go and what does it go over? What voltage is it? How do you decide one from the other? And that can be whether we're talking about sending data over coax, over fiber, over Wi-Fi. You can have different forms, but at the end of the day, you're getting ones and zeros to get it between the endpoint devices, which is where, for instance, in a data network, a switch, it's how you frame it up into packets. And then it gets passed up to the 3rd layer, which is where we deal with the networking, the IP addressing, things like that. You have the 4th layer, it's where we break it up into sessions. And we'll talk about some of the alphabet soup here later, the TCP sessions, the UDP, how it's transported. Once you get up into layer 5, we're getting into extended sessions of how the programs trade data back and forth. Layer 6, presentation, it's how we translate between the network data and the actual application you're using. Encryption, decoding graphics, that sort of thing. And up at layer 7, that's the layer you interact with it. Your web browser, your mixing console, your streaming, anything like that. So I'm going to try to go through and sort of follow it by layer, but because something's sort of cross, we're going to break some of that a little. But let's start in the networking world talking about the physical layer, how we get the data ones and zeros around. The most common way is on cable, which is twisted pair, or maybe not twisted pair. But what we're used to when we're talking about cable is we're talking about the various CAT cables. The ones you see most, we used to see Cat5, that's gone away because it doesn't really serve a purpose. It's been deprecated. You see Cat5e. Cat5e, it's a twisted pair cable for twisted pairs. It can be either shielded or unshielded. Cat-E is good for hauling data at a rate up to 1 gigabit over distances up to 100 meters. The next step up is Cat6, which can do 1 gig out to 100 meters or 10 gig out to 60 meters. You go up, you get into Cat6a, which is individually shielded, and that can do 10 gig out to 100 meters. Going up there, the next hop up is Cat7, which is individually shielded and overall shielded, but it can do 10 gig to 100 meters, but now that we've got Cat6a that can do it as well, it really doesn't serve much of a useful purpose to us. And there's also Cat8 out there, which is really getting to things we don't have any application. It's mostly used in data centers. One thing worth mentioning is that Cat cable can be either solid or stranded. The stranded stuff is cheaper. when you're terminating it, you'll get much more reliable terminations because individual strands are less likely to break on you or less likely to slip out of the contacts, but it can be very stiff and kink on you. The stranded stuff is much more flexible, but harder to terminate. General rule of thumb is if you're building your own cables and running them, you're going to be better off doing the solid cables. If you're buying pre-made patch cables, you're going to do better in stranded. It's probably worth a word about cable, which is it's something we hang our entire show on. And it's something that people tend to think of as a little more durable than it maybe needs to be. It's really something that we can start to think about as a consumable if we're really depending on it for our shows. You know, 100-foot hunk of decent Cat6 pre-terminated molded strain reliefs is going to run you around $16. Roll of gaff tape will run you, what, 20 something? I'm a big fan of not betting a show on something that's cost me less than a roll of tape. So something to sort of think about. Something else to think about with your cable is because we run at fairly high frequencies, just because it tests good at DC with a simple cable tester, continuity tester, does not mean it's going to work. So if it's been crimped, if it's been slammed in a door, if there's anything about it that suggests it's maybe been compromised, my advice is just get rid of it, because you just can't tell with the cheap continuity tester. There are ways to use, there are more specific testers, and even some network switches have a test function that will test it and show you what length it is, which will give you a good clue. If you go to test a cable and it says, hey, pairs 1 and 2 and 4 are all 75 meters long, pair 3 is 32 meters long, you've probably got a problem and you need to discard that. As far as terminating them, the most common schemes when we're pinning them out are what are called T568A and B. A was sort of where it started, but B is pretty much what everyone's using now. The only difference between A and B is in A, the orange and green pairs are reversed. When you're pinning them out, one thing that's important to know is the pairs are not straight across. I see a lot of people who will simply pin it, pins 1 and 2 one pair, 3 and 4 another, 5 and 6 another, 7 and 8 the fourth. The problem is the way it actually pins, if you look carefully, 4 and 5 are the blue pair, 3 and 6 are the green pair. So if you're making up your own cables, you can get in a lot of trouble doing that because at least one of your primary pairs you're sending data on just got split and you're going to have interference problems. So it's a real important thing to realize you're not going straight across. Another interesting thing about it is if you're using 100 meg internet instead of 1 gig, 100 meg only uses 2 of your pairs as opposed to gig, which uses all 4. And 100 actually uses pair 2 and pair 3 only, and pair 1 and 4 are unused. You can actually use that as a cheat on a show. And I think most of us who've done this for a while have had to do this, because if you only need to run at 100 meg, you can actually split the cable and run one circuit on 2 and 3 and one on 1 and 4. There are also people who make things they call passive PoE injectors, where if you need to run a piece of equipment remotely that isn't true power over Ethernet, you can split those conductors out and use them to remotely power something. Sorry, I'm gonna go back to one. So these connectors are probably the weakest links we get into because those little tabs break constantly. And again, don't bet your show on it. If you find a cable and the tab doesn't lock in, just get rid of it. There are much more ruggedized connectors. Neutrik makes the EtherCon series, which basically put an XLR shell around this connector. And you can plug them in or unplug them, take them in out of the shell. One of the big traps to be aware of, when Neutra came out with the EtherCon, they made it for a 5e. And down the line, when Cat6 cable we started to see more of, they said, okay, we'll make a Cat6 connector. For some reason, they decided to make the Cat6s physically incompatible with the Cat5s. A lot of people didn't think that was a really good move because you had two very similar looking things with compatible cable that couldn't plug in. So they came out with the Cat6A, which is compatible with 5e. So if you're using ruggedized cable, one thing you have to be on the lookout for is you have 3 different grades of connectors. 2 are compatible, 1 is not. The 6s pretty much haven't gone anywhere, but you do find the stuff somewhere. The 5es are what we see the most on all of our equipment. So after copper, the next thing we started getting into is fiber. Fiber is something not to be afraid of, and it's something we see a lot more, because with fiber, you can carry a lot more data and over a lot more distances, and you don't have to worry about electrical interference. There was a time when copper was prohibitively expensive, particularly the interfaces, but they've gotten dirt cheap now. I did a project recently where I was looking at manufacturers' interfaces at like $870 each, and found out I could replace them with generics for $34. Figure the good old days of running an analog front of house snake with 54 pairs and what that costs versus a pair of fiber and 2 $34 interfaces. It gets really attractive really fast. One of the things that is not immediately obvious with fiber that it's useful to kind of be clued in on is color codes tell you a lot. As a general rule, when you see fiber, if you see fiber that's yellow, that's single mode fiber. Single mode can go a long distance. We also have multi-mode fibers, which come in 4 different classes. The older styles called 1 and 2 are usually orange, and they have a larger diameter fiber and can go much shorter distances at lower data rates. The aqua stuff is OM3, OM4, which is the newer multi-mode, and go longer distances. Now, this is what you're going to see in patch cables. What you will see is, if you get in the broadcast world, you'll see a lot more black tactical fiber, which is a much tougher outer jacket, and you can get multi-strand stuff up to 12 or 24 strands, which has different color codes inside. So color isn't a guarantee, but it's a good guideline. In terms of those fibers, the OM1s, OM2s, the orange ones, had an initial fiber inside that was 62.5 micrometers and 125 outside, which is standard size. You got to the OM3s and OM4s, you're at 50, and the single modes are down to 9. The reason they call that is the diameter of it, the number of paths light can take to get from one end to the other are called modes. And in the larger ones, it can bounce back and forth. The smaller ones, it follows only a single path. So that's why the larger, slower fibers have a much more limited distance. The single can go for miles, literally. One thing to be aware of, if you ever have to work with this stuff, 9 micrometer fiber is tiny. If you're ever in an area where they're working on it, the shards are invisible. They're tiny little needles. They'll go right through your skin. So be careful of those. Next thing to talk about when we're talking about fiber is how they're mounted, because the way the ends of those fibers connect to each other affects how well they transmit. How much you get where they interface, you'll get some reflected back and some that goes forward. So there are a number of polishes, and you can either use flat, we really don't see anymore. PC is a physical contact, which just pushes the ends up to each other. UPC is ultimate physical contact or ultra physical contact, where the tip is rounded, so the smallest area possible makes contact. And APC is angled physical contact, where it's actually beveled at an 8-degree angle, so you minimize reflection. Another useful thing to know here, and I don't think I have a slide, but I found this one out the hard way on a roof in Chicago in a February morning at dark 30, is if you mix and match contacts, you'll get a mismatch, just like an impedance mismatch in an electrical system. You'll get loss. If you try to put an angled connector up against a PC connector, you can lose like 30 dB in level. So another useful bit of color code you'll see is any of the PC or UPC connectors will typically have a blue boot, and the angled ones will have a green boot. So if you pick up a yellow cable that has a green connector on it, you know you got a piece of single mode with an angled connector. Now, one of the downsides of fiber is just the number of connectors. I literally went through slides that had dozens of them, and I said, we're just not going to do this. The most common ones you're going to see are top left, the LC connector, top right, the SC connector. The LC is basically a latching. It slides in and latches just like a modular connector. Your SC is a push-pull. The FC, which is a thread-on, which you see a lot in the angled polishes, and the STs, which is a little mini bayonet, just sort of like a BNC. If you spend a lot of time around TV trucks, you'll see a lot of the STs. Likewise, if you look down at the bottom, the LCs and the SCs are available in duplexes where you have sort of a twinned cable that you can make two connections at once. One of the things you have to be aware of in fiber is generally you're going to have one side that transmits and receives on the other end and one going back. So if you're plugging two cables between two fiber transceivers that have a transmit side and a receive side, you can accidentally plug transmit to transmit and receive to receive. One of the first things you find if you're plugging fiber and it isn't working is check that and make sure they're properly reversed. If you're using the duplexes, they usually build them so they put the connectors on each end reversed upside down, so it'll get that right for you automatically. And just before I hop off, one other thing, a lot of the fiber systems, I thought I'd put something in here on this, they can work at a variety of wavelengths, and you have to have the same wavelength on both ends. The single mode stuff usually works at 850 nanometers, and the single mode usually does 1330 or 1350 or 1550. One of the things they can do to save strands, because you normally have to have one strand and one for send and receive, is that they can make dual wavelength interfaces. So it'll run 1350 one way for transmit and 1550 the other way for receive. So you only need to use half as many pieces of glass. Hopping a little bit up to the types of data on the network. We basically,
sorry, Justin, before we move on, does anybody have any anything they want to ask or talk about with cables before we get to the the next topic? Chris, is that a hand or are you just playing with something?
No.
Alrighty, moving on then.
Okay, now this is an example of me doing something out of order, but these are words we're just going to use so much more going forth. We really ought to talk about them now. When we're sending data on the network, we're moving packets between devices. That can happen one of three basic ways. The first, and the one you probably think of most, is unicast. You're sending directly from one device to one other device. They're just one-to-one and they're exchanging data that way. The next thing is multicast, which is we're sending from one device to one or more than one device, but the devices can opt to receive or not receive a stream of multicast data using a protocol called Internet Group Messaging Protocol. We can get into that maybe a little later as we get into use cases. It's something that has to be actively managed with devices requesting subscriptions and a switch deciding to send it or not send it to them, depending on what they're requesting. And that's very useful if we're doing things like streaming audio or streaming video, because sending a single stream multiple times out to multiple destinations can really clog up your network fast and be a problem. The downside to multicast is, by default, it floods it out every port unless you use IGMP to manage who gets it. So again, different ones have different use cases. And the third, which we don't do much with, it's more on the network management back end, is broadcast, which is a lot of the network management traffic, which sends it from one host out to everybody on the network segment and no choice on receiving it. And when we talk about network addressing again, I can talk about sometimes there's ways that can trip you up. The next thing we hear kicking around a lot, another was acronyms we hear a lot that isn't clear. You hear talking about TCP and UDP. This one thing happens up at layer 4. TCP and UDP are two different ways of sending data packets between devices. TCP is the transmission control protocol. It's all about making connections between things. So before it actually sends data, the two devices handshake and say, yeah, we've got a connection, and they exchange some initial frames to set up the connection. So when you're sending data by TCP, it sends the data, it says, the receiver says, I'm ready to receive. The sender says, okay, here's the packet. The receiver acknowledges it and says, I got this with no errors, or it says, I got this and there was an error, resend it. And when it resends it, the receiver actually says, hey, I'm getting your data, and right now I have a buffer that can take this much more data, or hey, you need to wait before you send me more. So it really lets you manage the flow, and it gives reliability. The problem is, because you have that back and forth, it's a lot slower and there's more network traffic. Exchange that data adds more headers, which makes your packet sizes bigger, which makes more network traffic. But it does give you acknowledgments, so it is a much more reliable means of making sure your data got there. If you send data, or an application sends data by TCP, you know it was successful, you know nothing got lost. UDP, on the other hand, is connectionless. A client basically sends a request, said, hey, I'd like to receive this UDP data stream, and the sender sends it. And it'll sometimes send it several times over, so you get it, but it just sends it out. They don't handshake. It only does error checking in the sense that when the sender sends it, it'll put a checksum on it and says, hey, all the bits in this packet add up to this number. And if the receiver gets it and they don't add up, it knows it's a bad packet and it discards it. Because it's one way and there's no connection, no error checking, it's a lot faster, and it uses much smaller packets, but you don't know it's there. So it can be much more handy in things like streaming applications, because if you're sending a big file, an application, a document, you probably want to send it by TCP, because if that file gets corrupted, you want to know, and you want to know that you have to send the data again. If you're doing streaming stuff, you see a lot more UDP, because, you know, if I'm sending a bunch of audio at 48,000 frames a second and my bundle's got 4 channels in it, if I drop a frame, I just double the 48 seconds before on playout and no one knows, but it's much more efficient. When we're doing packets, we just talked about that you can send stuff either, my apologies. You can send stuff either TCP or UDP. TCP is always a one-to-one connection and it has to be connected, so it can only work unicast. Anything that's going multicast or broadcast, by definition, we are sending it from one sender to multiple receivers. So since there's multiple recipients and you don't know who they are, multicast and broadcast can only be UDP. So that sort of limits you in what you can do. Let's move on to the magic world of addressing. Again, I had to take some things out of order, but if there's a worth the price of admission tonight, I think getting addressing and subnetting is going to be one of them. When we're talking about moving things at layer 2, when we're moving data between switches and other devices, it's actually not based on the IP address. It's based on the MAC address, the media access control address. And when you get higher up, there's actually a table in the devices that matches the MAC address to the IP address. And switches actually keep track of which MAC addresses they've been able to see on which ports. So when you look at a MAC address, it's actually got 6 hex blocks, and they actually split into 2 parts. And this can be very useful when you're playing hide and seek with something. The first half of a MAC address is what's called an organizational unique identifier, which is a really fancy way of saying who made this. So different companies, when they start making interfaces, because every interface has a unique MAC address that only it in the world should have, the company that made it gets that OUI block. So you can actually look up on the internet, you know, if you see a MAC address and say, what is this thing that I'm seeing? Why is it showing up on my network? You can actually go to the internet and search, you know, OUI lookup and type in the first half of the MAC address and find who made that thing you're seeing, which can help you narrow down a mystery thing that's on your network. The second half is the specific address to that device. So once the company has filled all of those network interface specific ones, they go back for another OUI block. It's kind of bad news, because if somebody says to me, you know what'd be handy? What's Apple's OUI block? Well, they've been back to the well dozens and dozens of times. There is no Apple specific block. You just have to go do the lookup on the device you're looking for and see what it is. So next up, IP addresses. We're going to talk, they exist in both version 4 and version 6. We're talking exclusively about IPv4 tonight, but it is good to know V6 is out there. IPv4 is the version you're seeing. It's got 4. Yes, Omar.
Hey, sorry, I just want to give a quick break real quick. Adam Berlin had some feedback on something you were just saying real quick. I wanted to just have him jump in here and give us his perspective.
Absolutely.
Hey guys, just want to, I know I have experience with fiber. I'm just letting you know, I know you didn't bring up the idea of, cleaning fiber. I don't know if are you going to bring that up, Justin, at all?
I was not going to do too deep into a fiber, but, absolutely with fiber, cleanliness is next to everything.
Yeah, it's most important. I'll be right back. I got the fiber cleaner, right? Be right back.
Oh, excellent. Yeah, no, if we get further into fiber, we'll hopefully see a fiber cleaning kit. Now, because you're dealing with fibers, 9 microns across, a speck of dust is a boulder. And can either fail your
fiber cleaners. So yeah. I actually have experience with fiber myself. I work in broadcasting.
Yes.
And so this is the number one thing that, being a utility on site, I'm always cleaning all the fiber connectors and from
those are great.
Yeah,
those are great. They got the little click pens. And they also make really handy microscopes to let you get a good look up on the end of your fiber so you can see if it's clean or if there's dust on it. I'll be honest, fiber is something I really skimmed in, because the simple truth is doing, 2 or 3 hours on fiber alone is an easy topic. But yes, thank you, Adam. That is something that was worth a mention, because with fiber, cleanliness is everything. And as a little tangent off data net, sorry. Yes, I am.
Yeah, I just wanted to say one other thing is that when, I have a lot of in one of the laser pointers for during especially in broadcasting, because to try to find the connector of what you're working with, just because sometimes it can be mislabeled from the panel to the field. Just to shoot a laser is the easiest thing during those processes, and especially in a remote setting.
Yeah, no, a couple things, and I'm going to just riff on that for a minute too, and then we'll get back to the wonderful world of addressing. Yeah, the laser pointer or a visual fault finder can be great. Also, if you get a piece of fiber that's been kinked or damaged in the middle, you can actually with a laser see the light leaking out of it. If you're working a lot with fiber, absolutely you need to be carrying cleaners. And you can also, for a pretty cheap price, get a laser source and a level meter that will show you the dB of loss through your fiber, which can be very useful in troubleshooting. And stepping aside from data for a second, there's also, if you start to deal with RF, there's a lot of RF over fiber systems. The catch with them, which is a little different from here, is they're not running digital, they're running analog. So cleanliness and level loss are a huge thing in those worlds. But yes, thank you for jumping in with that, Adam. That is a very good point, and I apologize for not bringing it up.
Yeah, no, I'm new to the group, so I'm just letting people know.
No, welcome. Yes, thank you very much.
Who I am and whatnot.
So back to the world of IP. Just for some context, IP is what we're used to seeing. IPv4 was what they started developing the internet on back in the 70s. I have no idea what happened to V1 through 3. I have no idea what happened to V5. But you're going to recognize that it's that typical 3 octets dotted. And the reason we call them octets, we'll get to in a minute, is because each one represents 8 binary bits, and we'll show that in a little more detail. Officially, we ran out of IPv4 addresses on the public internet back in 2011. So we recycle them by using some private ones internally, which we'll look at a little more.
Quick fun fact.
Yes.
How you were talking about IPv4, where 1, 2, and 3, we don't know where it went. The reason why it's called IPv4 is because the octaves, there's 4 separate octaves that connect you to the internet. That's why it's IPv4. There was no 1, 2, or 3 because there was 4 decimal octaves of connectivity between server, microserver, internet, and browser situation. So that's why there's 4 octave levels.
Oh, cool. See, I learned something new tonight. And you'll get a chuckle when I beat up on classful addressing in a minute. So IPv6, the new standard, it's a much longer address. If you look, IPv4 had 4.3 billion addresses, IPv6, 304 undecillion. The theory is we'll never run out, because when they did IPv4, they joked about, well, it's never like everybody's going to have light bulbs that need IP addresses, but here we are. So, did I just knock myself out? Sorry. So IPv4, as we just said, it's 4 blocks and each one is 8 bits. So if you translate it into binary, that's how it works out. And the biggest value you can get is 8 ones equals 255. That's why you never see the numbers above 255. So 0 is 8 zeros and 255 is 8 ones. So that's why we never have a 256. So that's how the octets in an IPv4-6 break out in each of the dotted sessions. Which now brings us to subnet masks. And we're about to go way down this hole. If you look at an IP address in decimal, if you look at 192.168.100.1, it breaks out in binary as written below it. If you look at a subnet mask of 255.255.255.0, you notice something pretty quick, which is any of the 255s translate to all ones and the zeros are zeros. And we'll talk about now things in between in a minute. But the way a network sorts out what part of the address identifies the network it's on and what part identifies the particular device or host is it holds the decimal of your address up against the decimal of the subnet mask, and anything that matches up with a 1 is a network address. Anything that matches up with a 0 is a unique host in that network. So yes, classful networks. I hope we never have to speak of this again because they're dead, Jim. In the early days of the network development and the internet, they came up with a system of classful addressing where they paired everything off officially based on the first 3 digits in binary of the network and basically said, these ranges are class A, these are class B, these are class C. One of the side effects of that was each range wound up with a different mask size. And a lot of people today still talk about a class A network, a class B, a class C. Classful networks were a thing from 81 to 93. For perspective, the first web page came online in 92. By 93, INA had decided it was just a bad idea and abandoned it. And instead, they went to what they call CIDR, or classless interdomain routing, which has been the official standard since 93. So yeah, classful was with us for 12 years, has been deprecated for 27. Kind of makes me nuts when we still talk about it, because classful locks you into very specific network sizes. In the new world, CIDR, classless, you can use a variety of net masks and you can divide your networks up however it suits you. So it's a lot more flexible. So if you look down in CIDR, on the column here on the left is the binary representation. If you go over to 2 columns over, you'll see the standard decimal net mask, and 2 more columns over, you're going to see.
Sorry to interject again. I'm being yelled at privately, I guess. So we were going over, when you were going over the 255 in each point of the IPv4 and how it has 255 subnets, basically is what that is. It's a hexadecimal. That's a 16th of a subaddress that can be found. So that's where the 255 number comes from, is each one that you're representing is a 16th of a subdecimal, which is what calculates the 255. That's how when you miss 1, 1, 1, 1, 1, 1, and you miss 1, it comes out to 254, is because that last hexadecimal is only a 16th of the subaddress that you're trying to find. Where you get 192 is the mishaps in the 16th missing. So that's why you'll notice when he was explaining it, you have like 192.168.100.1, which is an IP address that you can find commonly. The way the ones are laid out are a 16th of a hexadecimal somewhere that's addressing you to that portion of the internet or that portion of data that you're trying to transmit.
Well, I think the interesting thing, I might take a slightly different view, is when you're working in CIDR instead of classful, you can actually split those ranges up differently.
Correct. Well, that's where IPC6 comes in, is it allows you to go even further into that micron to 128 of a decimal to find those different IP addresses and those different network subnets. Sorry, I'm a geek. I'm a nerd. As you can see, that's what...
Oh, no. Hey, that's why we're all here, and I'm all in favor.
I love this part of it because this is what I geek out on. I can literally script down to an IP address, and that will keep it clean for Facebook. Basically, I can make a computer do what I want to do. I'm a very dangerous man with a computer.
Yeah,
let's just put it that way. And that's how you use it when it comes to those particular tasks, is breaking down subnet addresses to find the information that you want. Yeah, and I'll go quiet and let you continue.
Oh no, I appreciate the contribution. But the thing with CIDR is we're not restricted to what people thought of as old A, B, and C sizes. So yeah, if we're talking about, and I'll beat up on 192.168 a little later, I'm not a big fan of it in a production environment.
Anybody who does production audio, any type of data transfer inside of an event should not be friends of 168 at all.
Here's
Just plain and simple. It's an open source net. It's an open source net that gets clogged very easily. That's why you should have your own masking, which I'm sure he's going to get into, and tell you exactly how to do it. So that way all your communication between all your devices communicate without interference from any outside sources, like wireless devices in a studio that are connecting to the same internet. I'll let him continue. And
oh no, that's a great chance for
let
me
him
to
continue before I say something, okay?
No, it's a great chance to make one of my pet peeves. You know, the way I like to explain 192.168 in a production environment is, imagine I go onto a show and I'm loading in, and we're 2 days into load in, and I come into the crew meeting at the beginning of the morning and say, hey, here's the deal. So there's no confusion for the rest of this run. Everything of mine, every patch cable, every piece of equipment, every power cord, I have carefully labeled, and it's all in black Sharpie. So it's black Sharpie, it's mine. What are the odds somebody else has a black Sharpie in their pocket? Pretty darn good. So I complain that 192.168 is the black Sharpie of networking. And yeah, you're gonna get into trouble using it. We'll get down into a minute into all of the private ranges that are available. And my advice, yeah, Omar.
Okay, I gotta ask. So when I do 192.168.100. whatever, I'm always on my own. I can't think of the word right now. I'm always on my own like command or whatever it's called within my IP. So like I'm on my own network for video, not on anybody else's on that router or anything else. It's my own thing, my own stuff with my projectors and my switchers. So no one else is really tapping into that unless they got into my router. So is that even, I guess, in your opinion, that is still a bad kind of?
I have two concerns with it, and the reasons I don't do it. The first is your chocolate's my peanut butter, my peanut butter's your chocolate. If somebody cross patches something and one network gets plugged into the other and you're using the same address ranges, it's going to take you a while to notice it. The second thing is, as we do more and more complex show, we start having to route things back and forth. And in terms of routing, in the data sense of it, you can't route between two identical networks. So
in simpler terms, 192.168 is a generic. So therefore, anything you're plugging in most likely is going to be accessed by 192.168.
Yeah.
So that's why he's saying, that's why it's like the Sharpie, because every one of you guys on a damn event carries a Sharpie, and you mark everything up and confuse everybody else that didn't do it. So 192.168 is that Sharpie that Omar labeled video projector, and some other guy came and said, nope, this is an audio cable. That's what that is. And that's, in simpler terms, it's just basically you're doing video on 192.168. Somebody's doing audio on 196.2.8, and somebody's doing projection on 196.2.8.
Yeah.
Your 100 might be different, but how easy is it for them to go and mess you up and connect right into yours?
Yeah. And one of the other, I'm getting a couple slides ahead of myself. We'll talk about the problem with getting two DHCP servers on one network. And if you're both handing out the same address pool, it's going to be a mess, and it's going to take you forever to find. So just to wrap up a little more here with CIDR, and maybe have some people disagree, but one of the charms with CIDR is you're not constrained to network sizes. So, kind of what Bodie was saying, the standard 255, 255, 2550 used in a like 192.168.0 would go from 1 to 254, but CIDR takes the limits off, so I can make that 255, 255, 2540, and now it'll go 192.168.01 to 192.168.1 254. So you can make those ranges as big or as small as you want. Same thing, a lot of people, when they're talking about, the 10.0 ranges, we'll get to that a little more, sorry to pick some orders. think of them as 16-bit ranges where you have like, 64,000 possible addresses. But at the same time, I can dial it all back to 32-bit or 31-bit where it's 255, 255, 255, 254, where there's only 2 hosts, or go to, 30-bit where there's 4, which, at my day job, I coordinate with the campus IT department. They said, here's a 20-bit block. So, you have 4,000 addresses, stay within it. But then I have 4 venues and auxiliary areas. So I have a server network, a network management network, Dante primary, Dante secondary, QLAN primary, secondary, 4 spaces of lighting, 4 spaces of audio. But you can take that one block and carve it up into chunks as big as small as you want. I mean, I have some that are 24, some that are 25s. It gives you a lot of flexibility. So once you kind of let go of that old classful mentality of saying, hey, it can only be this size, you can start dividing your networks up a lot more flexibly. Anything further in there?
I think we're going to let you continue.
Okay. Yeah, I'm sort of watching the clock, and I go with my bet that I'd hit an hour without trying. So when we're addressing, one of the other things we want to talk about is gateways, which is when you have a network, the network segment and the host segment, when a host sends a packet and it doesn't match the network segment, it automatically gets picked up when you send it. If it doesn't match something in the network, it gets sent to the gateway, which is an address, essentially the router. Traditionally, it's most often seen as the lowest address in the range, typically a .1. Sometimes it's put in as the highest address. I work in a place where, due to a bug with an old operating system, they do it highest. You'll see people who say it has to be the lowest or it has to be the highest. The truth is, you can put it anywhere in the range, just it's confusing as heck. So most of us stick to putting it at the lowest. Domain name service. I'm like trying to guess what I did or didn't skip over here. Domain name service, we come up with domain names that match the IP addresses with more human-friendly names. And you can actually do this not just on the internet, but locally. If I'm doing a show here, I might set up my local domain as Tech Talks. And I might, name Justin MacBook, Ed MacBook, Mixing Console. So if I'm logging into things, I can do them. So there's actually 3 levels of translation. You've got a human-friendly DNS name, which resolves to a network level 3 IP address, which resolves down to level 2 to the MAC address. You can have more than one entry. For instance, if you go to Google, or you go to Google and look up google.com, you'll find out it has a bunch of entries and it just round robins to them. And it can exist in 2 forms. It can either be run as unicast traffic from a DNS server where you say, hey, I'm looking for this name. Do you know where it is? And the DNS server will either return it or go up to a server above it and try at that level before it decides you can't. Or there's another form called multicast DNS, which we'll talk about more when we get into the horrors of link local addressing. It's also known as Apple's Bonjour, where instead of going through a server, when devices come onto the network, they advertise themselves and say, hi, I'm here, I'm at this DNS address, and you can use me by this name if you need to reach me. So methods of addressing. Static addressing, where you manually enter everything, the IP address, the subnet mask, where your gateway or router can be found, and 1 or more DNS servers. Once you put them in, they're fixed. They don't change unless you alter them. Manual addressing can be nice in that it can keep things from getting messed up. If you're going to do static addressing, I really recommend a system. When I'm setting up a network, I'll tend to have a hierarchy. I'll say, Anything in the tens is network devices. Anything in the teens is access. It's switching. It's wireless access points. Anything in the 20s will be desktop computers. Anything in 30 will be laptop. Odd numbers will be wired connections. Even will be wireless. 40s will be my mixing consoles. So when you look and you see an address come up, you have a pretty good idea out of the gate what it is. Some people don't like the fact that it makes you think about it so much. It's really what's your best use case. Next option, DHCP, Dynamic Host Control Protocol. On a network, you have a DHCP server that when a new device pops up on the network, it says, hey, I'm here, I'd like an address. And there's a negotiation process that goes back and forth between the DHCP server and the device, where it says, I'd like to use this address. And it says, okay, that's available. Okay, great. I'm going to confirm I'm using this address. When it grants a lease, they have set times and they have to renew after they expire. There is something to be very aware of on this in terms of best practice on shows. The first is you give it a pool of addresses to hang out. So if you tell the server, if you look, a lot of servers will default to something like 100 addresses. I've had shows where we've had 100 addresses available. They also have a lifetime. So once a device is given an address, it uses that address for the duration of the lifetime, and that comes back and says, hey, I need an address again. Normally the server will give it the same address. The up and down side is when a device renews its address, it may or may not get a dropout. Not usually, but it does happen. The problem is if you have a limited pool of addresses and a long lease time. I did an event, a fairly big event last year where they had an address pool of 100 addresses for intercom devices and had them set to never expire. By about the third day of the show, over 100 people had showed up with their own devices and logged off and logged on, and suddenly people are getting denied because all the addresses have been given out. So it's real smart if you're setting up a show to A, give yourself a big enough pool, and two, pick a lifetime that makes sense. If I'm doing a show, I'll typically do an address pool that lasts 20, 24 hours. So people time out at the end of the day, and when they come in for the call the next day, they get a fresh one. Yes, sir. Muted.
You're muted there, Andy.
Sorry about that. Could you just touch a few seconds on what types of equipment, internet equipment, have DHCP servers built in and what types don't?
And that's a hand grenade point. They can show up in all sorts of places. Now, said before, you only want one on the network, because if there's multiple servers, when a device pops up and says, hey, I want an address, they're all going to try to answer. Whichever one answers first, and you have the address. So you either get two conflicting addresses on one network, or you can get two addresses that are different networks and they don't talk to each other. The bomb there is that you can find DHCP servers in your consumer all-in-one devices. I'm going to have a thing about calling them routers later, but those tend to have DHCP servers unless you turn them off. A lot of standalone routers will have DHCP servers. If you're running a layer 3 switch, it can have a DHCP server active in it. Lighting consoles can have DHCP servers active in them.
Which is something I just found out, that the switcher that you're talking about has a DHCP server in it. I don't know what I was doing. Omar sent me something and I was looking at it and I decided to read it. And I'm like, why in the hell does this thing have its own server?
Yeah.
I'm like, there's no need for it.
Yeah. And there's been, I'll hopefully get to this. I'm trying not to go too much over time in presentation here. But yeah, I've also seen problems with, I'll pick on lighting boards for a second. One of the major lighting board manufacturers used to have a flaw in their DHCP service where it would try to negotiate things normally. but it would send the final acknowledgement package out as broadcast because everybody wants to sign their little iPad client into the lighting board. But it would send it out broadcast, and the Wi-Fi system would drop the broadcast traffic, so nobody would ever get an address. And it took some major troubleshooting to get to the bottom of that. And last but not least, link local, also known as auto IP or zero config. The addresses are not assigned by any sort of server or entry. They're pseudo randomly picked in the 169.254.0.0 range. There's no address server because there's no server, no centralized control. You can't use regular DNS, only multicast DNS between devices, and you cannot route them to other networks or to the internet. My personal opinion, when it comes to using link local on show, some people like it because it's plug and play and you just plug the stuff in, you go, and you don't worry about the network. My personal opinion, especially for Ed, it's a trap. Don't do it. And here's why. Because when you're using auto config addresses, like I said, you can't route between networks. So if you got two systems using them, you can never link them. In a world where we're doing more and more remote production, you can't get to them. You can't VPN in to a link local network, all of which is an inconvenience. Here's the hand grenade. Here's why I call this the hand grenade with the loose pin in the workbox. The DHCP thing. You can get link local addresses two ways. The first is if you have a device set for DHCP, and it doesn't get DHCP server, it'll time out and fail over to a link local address. The other thing is some pieces of hardware can be set to only do link local addresses. And here's what happens, and this can ruin your day, which is you've got your whole network set up for link local, and you're not worrying about the rest of this stuff. And then at some point, somebody drops a DHCP server on it. It can be a hit and run. It can be someone who takes a consumer router and plugs it in, and it suddenly hands out IP addresses. It can be somebody through a layer 3 switch with a server on the network. It can be, somebody plugged their lighting board in instead of the lighting network. The problem is, once this happens, half your devices have DHCP addresses in one range, half of them are still link local because they say, sorry, don't touch the stuff. Now, half your devices aren't talking to the other half. It gets worse because once they've got DHCP addresses, they hold them until you clear them and renew them. So if somebody has done this, you now have to go figure out if you still have a rogue DHCP server on your network. Pro tip, fast way to do that is take a laptop, set it for DHCP, and plug it in the network. If it gets a grant, the server's still on your network. If it doesn't, it was hit and run. And one more add to the ways you can get DHCP. If somebody's got their laptop set up for internet connection sharing, they will serve DHCP. So that's something to be aware of. So
that may or may not have happened to me at least once in my career.
Oh, I think everybody who tries to do link local is going to get bit at some point. Because some devices.
I think I called you frantically actually once about it, and it was screwing up. It screwed up a Rio that was on a little throwdown switch, and some Avios. But thankfully, my Dante secondary was holding and doing what it was supposed to. But,
I mean, not to get too audio, and I'm trying to be protocol and device agnostic, but some things like a lot of Lake stuff is defaulted to link local only. And like when your mixing console suddenly gets a DHCP address and your processors don't, you wonder why everything suddenly went silent. A couple special case addresses to be aware of. We alluded to before, there's 3 what they call private ranges. They're private only in the sense that if you put them on the internet routers will refuse to touch them. And this is good because we can recycle them behind internal networks over and over. Because like you said, we ran out of IPv4 back in 2011. So the three ranges are 10.0.0.0 to 10.255.255.255, which a lot of people use. And a lot of them tend to use it as big 16-bit ranges where they change the second octet. The one nobody uses, and it's a good place to hide because nobody's going to use it, 172.16.0 to 172.31. And of course, the black Sharpie 192.168 0 to 255. I really hate seeing it on show. It begs for confusion. And as you do more and more remote production, or you have to log in to a talent's home network where they're using on their home device, really just avoid it. But again, you can carve these up anywhere as you want. An address you notice you may not see is the bottom address in a network, the .0 in the bottom. Now, networks can start and end in different places. Like if I'm doing a 25-bit, .128 is also a valid start, but there are rules. I'm running over, so Google those if you want. But the bottom address in the range is off limits because it's the one that's all zeros in the host field and defines the network. The top address, the broadcast address, the highest address in the network, the .255s or the .127s are off limits because when they send out broadcast traffic, that's where it all goes. 127.0.0.1. It's also known as localhost. It refers to this machine here. It's also called the loopback address. And when you're talking about multicast, again, multicast has a bunch of subranges, not touching it tonight, but you can look them up. 224.0 to 239 is where all of the multicast traffic goes. And when a device decides it wants to subscribe to a multicast flow, it's listening to the appropriate address for that flow.
Anybody that's ever played with a Raspberry Pi definitely knows what the hell a local host is, because that's what you subnet everything back to to feed its communication to it.
And if you're a network geek, somewhere you have there's no place like 127.0.0.1, sure. And something that's just worth mentioning that I should have hit before, a couple other things that are a little special. So localhost is a reserved name in DNS. And I didn't mention this back in DNS, but there was a big tiff way back when. If a network was internal and didn't resolve to the outside world, Microsoft's recommendation was to make it end in .local. Apple got in the game and said, no, .local is going to be everything that resolves through multicast DNS. And for a while, they all got along. But, oh, God, I think around OS 10.13, Apple said, we're done. We're only resolving it to multicast, and you cannot work around it. At the time that happened, I was actually running a mostly Windows network with the .local name. Apple's suggested workaround was tell the Windows network to completely rename itself, which is about the most miserable exercise you're going to have. So be aware about using .local for anything but multicast DNS. Ports, one more thing worth mentioning is the idea of ports, which is the layer above the IP address, which a port can be either TCP or UDP. And it's basically, a way of tunneling further into that IP address to further subdividing it. So you can go to a standard port, like a lot of things like, HTTP or web traffic is port 80. HTTPS, secure web traffic is, yes.
Sorry, I know this is slightly off topic, but I'm a little late on it with the Facebook side.
No, that's cool.
So Henry Kahlo's asking, and I believe Justin can get on this as well. And his exact verbiage is, what I would like to know or learn how to do is while doing graphics, I want to know how I can set up this is his verbiage, like 4 PC Macs to network together. For example, if I upload a presentation to one graphic laptop, either main or backup or laptop, once I upload it to one laptop, it automatically goes to other laptops. I know where he's going
Ooh,
with that.
That's an
Justin, you decided
application
to talk
level
about
issue.
that? Yeah, Justin. you
That's
decided
an
to talk about that.
application level issue. That's not a network issue, for better or worse. Yeah, I'd love to have an easy answer for that, but so yeah, ports 443. If you're doing file transfer, it's 21, and you can make up their own. You know, hey, my favorite intercom app, we by default use 20201, but you can pick and choose them. It's just a way of pointing things. So a lot of times, if you're translating an app in from the internet, you'll say, you know, my public address, this port, send it to my internal address, this port, and return it. And a lot of times in a web address or URL, you'll see it written just as the address with the colon with the port number. And you are free to change or remap those. Just some basic hardware things, which is mostly just a setup to the point in the final slide. Network switches are either layer 2 or layer 3 devices. They're designed to move packets around at the MAC address level, but layer 3 can also switch between virtual LANs at the layer 3 level. Sadly, virtual LANs are at the if we get around to it list. It's a very worthwhile discussion, but no way in an hour. Layer 3s can also have that DHCP server, like we said. It's one of the ways you can get into that trap. They can be managed or unmanaged. The unmanaged ones are just plug and play, drop them down and go. Something you'll hear thrown around, old-timey term, hubs, which is switches look at where a MAC address can be reached. Hubs used to just blast everything all broadcast all the time. Switches can also be used to inject power for power over Ethernet if you're using things like those Avio adapters Ed mentioned, or remotely powered access points, pan tilt zoom cameras. And there is a useful configuration if you start getting into spending a little more money, but it makes your life a lot better, is stackable switches where they have a link that interconnects them. And you don't have to worry about what traffic's flowing between the individual switches because it loops all of it. And when you go in to manage it, you're managing it as one big device. So you don't have to worry about logging into one switch at a time. Routers. Okay. Routers, when we're doing different subnets, this is how we swap traffic back and forth between them. And some traffic does not pass routers well. Basically, you're looking, and anytime you say, this isn't in my network, you're passing it to the gateway address. And that router looks at it and says, do I have another network connected to me that'll match to this? And if it doesn't, then it passes it up to the chain to the next router. Now, if you hit one of those private addresses and send it to a network router, it's going to kick it back and go, nope, not touching this. And if you get all the way up through the chain and come back, it's going to return that the host was not found. And last, you know, if you don't see this one coming, wireless access points are basically a way of converting the media between wired and wireless networks. You can either see them as standalone, which is the way most people encounter them, or you can see them as a system with a central controller that does authentication and security and a bunch of other functions. Half why I mention that is you can also hit traps. The good folks from Cisco, a lot of times you run into their centrally managed Aeronet systems. They won't let you do broadcast traffic, which is where we hit that problem with the lighting board. They also won't pass link local traffic. So if you're running anything link local, you're not going to be able to get to it wirelessly. A lot of home units don't have that restriction. A lot of enterprise ones do. It's another strike against link local. There's multiple forms of authentication and security. One of my, boy, I'd love to talk about it in the roundtable or later, is security in our world, because we just don't think about it enough. But they can have various forms of encryption, or you can authenticate and log in. One of the big problems, they add latency and instability to your network traffic. So you either have to live with much longer times, there's going to be a real problem with streaming, or you have to spend a lot more time buffering. Obviously, They have problems with radio interference that wired connections generally don't. Throw your 100-foot network cable in the middle of a coil of feeder running 300 amps. Okay, we'll talk. And they're basically a media converter. And you can also have media converters that take you between Ethernet and fiber optics. And last but not least, the all-in-ones. The ones most people say, I brought my router. They actually mean they're all-in-one. Home internet appliance. I really try to not, I fall prey to calling them routers too, but I try not to, because routers are about moving data between different networks. The all-in-ones, the internet side is one network, your inside's the other. They got a bunch of things. A lot of them have a couple ports of unmanaged switch. They have that DHCP server. They have a firewall to manage what passes to and from the internet. They can have that access point. In my funny nicknames, I call these the minivans of the network worlds, because they do a bit of everything and they do it adequately, but they're not really specialized for any of it. So, for dollar for what you need for simple setup, they're great, but you don't have the management you need when you get into higher end stuff. And like we mentioned before, sometimes somebody says, hey, the Wi-Fi back here is awful. I'm going to grab the little router out of my tech kit and plug it in, and all of a sudden a DHCP server just appeared. So you need to be aware of it. Started getting to the end. That's the end of the major presentation, because I figured I'd be over an hour by now. But yeah, there's a bunch of other stuff, if we want to bring these up in conversation, or if we want to do a networking 102, talk more about virtual networks, link aggregation so you can get better bandwidth or redundancy between your switches, rapid spanning tree protocol, which is a way where you can make redundant paths in your network, how we deal with network time and precision timing in all the streaming protocols, quality of service, the network equivalent of no after you holding the door, and IGMP, all those things. Yeah. So I'm going to bail out a presentation now, because this is all stuff we can kick back to or, explore more in future presentations. But that's the ground level overview. Now I can see all the messages.
That was great, Justin. It just for how quick we just went through that just tells you how much there is to understanding networking at an expert level.
Yeah.
What you just ran through in an hour, you said, what was the course you said that?
What I said is, if you're getting started in professional IT, the gold standard entry certification is the CCNA, the Cisco Certified Network Advisor. The general rule of thumb is, if you're going to get it, you need to buy the appropriate pile of hardware at home and dedicate yourself to spending 3 or 4 hours a night on it for 6 to 8 months. So yeah, we just tried to blitz that in an hour.
Exactly. Yeah. So, I think, first, does anybody have any questions on the panel? I know we covered a lot of information, but I'm sure somebody has to have a question. Andrew, we'll start with you. If you want to unmute.
Sure. Do you have any suggestions on ways to monitor the quality of a network? So let's say you have a Dante network or something like this. Is there some sort of application or product that you can kind of hook up to the network and go, yeah, it looks like everything's going smoothly, or losing this many packets, or the network's just on the edge, this kind of thing? Generally I end up having to troubleshoot things just by replacing cables. It would be really nice to know, hey, you know what, this is rock solid, but or it's just on the edge. It's either like go or no go. Is there anything you can do to test this stuff?
There are several ways to do that. And it depends on the application. Things like Dante, you've got Dante controller, which will show you, are we having drop packets? How many uncorrectables? How's the latency holding up? Are we seeing sync errors? So that's application specific. At the network level, there's some switches will show you, if you get into the managed switches, which give you a lot more power, but you're going to learn, but hey, good for the day rate. The managed switches will show you how many drop packets you're getting, how many uncorrectables. There's also a whole nother world in network management, a protocol I wasn't even gonna touch, SNMP, Simple Network Management Protocol, which lets you either query a piece of equipment for its state and its status, or have it send you alarms called traps when something happens. So you can have the switch send you a trap that says, hey, this port just passed 75% loading, or hey, my CPU is overheating, or hey, I'm getting packet loss. So yeah, there's a number of ways to get that. I mean, Dante is the closest to, a plain easy. As you get more into the advanced network management, this is the world of the Star Wars network operations centers. But yeah, certainly at the switches and the SNMP monitoring level, that is all available.
Yeah.
Great. We had a question come in on Facebook from David Kilkenny, it looks like. I had an issue with a live stream a few weeks back when I was on site. I was told I can't plug into the router as it sends voltage down the line to power the turnstile scanners. How can I get by that if I have no access to the router's management or the person that manages it? That sounds like PoE, I'm guessing.
It is PoE, and how should I put this politely? The issue is more the person that manages it than the management, because you can plug a non-PoE device into a PoE port with no issue. Sort of like phantom power on the mixing consoles. You can plug a dynamic mic in and you're going to be fine. So yeah, that's really, unfortunately, it's a diplomatic issue about talking with the house IT department, because from a electrical issue, it's not a problem. Although again, depending on how they work, streaming in, taking data that's being streamed in from a distribution server is a lot easier. If you're trying to push out to a distribution server, you need the outbound access. And if you're in a situation where the distribution server is pulling your stream from you, then you have to negotiate firewall at the house IT shop. So yeah, a lot of it, especially when you're working in corporate or educational headquarters, this is as much a diplomatic task as a data task. And before the next statement, I should also say a lot of the manufacturers, Audinate, et cetera, have nice white paper specifically to send to house IT departments to kind of answer things. Hey, it looks like.
Sorry. So thank you very much for your talk so far. I wanted to present what is probably a very simplistic, just kind of case study, but I've definitely sweated it over in my early days. Probably at this point, most people on here could answer this, but I know that there's probably guys who tuned in for networking and are curious a little bit about, some of these on-site, very, very simple things, but they get in your way and you spend time Googling, trying to figure them out. So for example, let's say I take your advice and I don't want to be that guy that shows up with 192.168. I want to be a network hipster. I've got my esoteric, whatever, 172 something. I've built a rack that's got like great, never going to be duplicated addresses. And I show up on site, I've got my companion, my stream deck, and I'm ready to control them. And the guy that I work with all the time who hired me also has his rack. And he's like, by the way, can you control my rack too? Just plug in. I've got a bunch of 192.168s. So what is the solution there so that your one host computer's controlling everything? Is that, is that an addressing issue? And then simultaneously, there's also, you also need to use internet on your device. So they've brought you a hard line and you need to get over your connection back to your computer, internet. So if you could just kind of walk through what would be the solutions, either hardware or addressing, that would be great.
Controlling the other rack can be one of two solutions. Actually, I'll go the other way. In terms of talking to the internet, this is where the router comes in, because any device on your network is going to say, okay, anything in my 172 network is local. Anything outside of that network needs to go somewhere else. Now, so the internet. And just as a trivia fact, something we didn't do, when a router assigns where things go, the last entry in the table is 00.0.0/0, which means the rest of the world. So if you have a router, it's talking to the internet. As far as your other rack, that can go one of two ways. If the equipment you're controlling has routable addresses and will talk over a routed interface, then you just add it to the router and you go, okay, 192.168, whatever, and the router sends the data to it. If you're doing something not routable, I keep picking on Dante, like Dante, then you got to readdress them to be in the same network.
Thank you.
I think Jason had a question. Go ahead.
Yeah, mine is a general. I have a ton of strengths. If I had to name one weakness, networking is it. And you've went through so much information in such a little time. I don't know if you've seen me, but I've been taking pictures of all your slides. I don't have 2 to 3 hours a day to go over this stuff, realistically, because, I have, like all of us, we have time constraints. But because I have on my own tried to find routes to learn this stuff, and I end up spiraling into these rabbit holes, getting stuck, and then learn 10 other things except for what I was trying to figure out. Is there somewhere, a manual, a book, or something you can point me in the direction to that I can pick up and read, and I don't spiral down these Google rabbit holes that take me 12 different places?
I'm trying to think of a good one off the top of my head. I'll certainly research a little and see what I come up with. I mean, that's one of the double-edged swords here. Is networking is one of the things that is very well documented on the internet, but yes, sometimes it's very, very, very well documented. But yeah, let me think a lot, because a lot of the protocols, all the manufacturers are doing things have pretty good setup or startup guides. My gripe is not all of them explain the why as well as the how.
I think the biggest thing for you to learn, Jason, just because personally knowing you, is when it comes to IP relations like that, it's not necessarily learning the IP numbers in a sense. It's knowing every piece of equipment that you're using and how to access their IP in order to coordinate it with the IP local network that you're trying to use.
Gotcha.
I can teach you, like we've already talked, when I build your computer, I can show you how to access the IP and access all of that for you. Gotcha. It's just the equipment that you're accessing to is where everybody's kind of gonna have to figure that out based on the equipment they're using. Most equipment guides should be very similar. From what I've seen, obviously I'm outside guy looking in, I'm not AV. So I haven't worked with all your switchers and all your soundboards and everything like that. But most of the stuff is pretty generic for the most part when it comes to finding the network protocol routing.
Right. Yeah, because I'm definitely the 198 dot whatever. I'm that guy. So, like I said, it is my weakness. I have, a lot of other things on the table other than that. And I need to know these things because, moving forward in this streaming world and all the gigs that I'm booking right now is all streaming. Some of them have, we have dedicated line internet coming to us. Some of them we're going to have to figure out ways to do this. And, if we're doing wireless or whatever the heck we're doing, or the live view or whatever, I want to make sure that it isn't messing up anything else. One thing works, but 10 things don't. And then my client is upset at the end of the day. I need to make sure that I'm on a level that I understand how to troubleshoot, rather than right now, if it doesn't work, there's usually somebody on site that understands networking like yourself. And I can be like, hey, bud, I'm screwed because of this. That is my weak point, 100%.
And
I think what I'm hearing is we need to do an AV networking basics is what we need to do, huh? A networking basis breakdown. Because I know, Justin, that your information was spot on and great and very informative for somebody like me. I can tell you right now, Omar, I can tell you right now, Jason, and I can tell you, Henry, watching at home, don't have a clue what the hell you just said. I love you all. No hate against you, but you don't have just don't have a clue, and I understand that. I think what we need is a basic networking, what connects to what, how host protocols connect simplistically to one another without getting into the 192.168 and all that, and showing how to change the default for all the communications to communicate with. I think that's kind of what I'm hearing from everybody, is that this was very informative, absolutely informative for the ones who know how to access that. But it seems like we need a more basic 101 when it comes to when you go on site. What do you typically have? Oh, I'm catching off of this router over here. Okay, do you have permission to access that router? No. Okay, well, who's the IT guy on site? I don't know. He doesn't show up. Oh, okay. He came in and installed the thing and he's never been back. Oh, cool. Type thing. That's kind of what a census across the panel.
Yeah. When
That-
on AV sites, we're like looking at each other and I'm like, hey, Ed, so like, do I change my subnet mask or what? And
By
he's
the way,
like,
my
I'll
name
call
is
somebody.
Christopher Brown. I'm learning to try to get into the AV world. I am your IT guy. If you need me, just give me a call. Hit me right up here on Facebook. Apparently, it seems like it's a needed thing in the AV industry. No,
Yes.
I'm playing, generically playing. I love every single one of you here, and I understand every single one of you have your own strengths. I was the geek at 10 years old building a computer in my room. My mom handed me parts and said, hey, some guy at work said you can have this computer. We just have to get it built. Well, back then, I'm 34 years old. Could you imagine? I was 10. 20 years ago, building a computer was $6,000 to $7,000. It was unheard of. I figured out how to build it myself, program it myself, load Windows myself, download everything. I am a self-taught IT guy. Hence why I don't have a job doing it, because I don't have a little piece of paper that tells everybody that I know what I'm doing. But I can, as I think I've demonstrated pretty well, I can handle just about anything when it comes to networking protocol, internet protocol, computer connections, creations. If I'm on site and the computer goes down, I could probably fix it before the show even starts. But that's just my background. I know not all of everybody that's in IT comes from that, or IT in AV comes from that background. You guys are more audio guys, camera guys, lighting guys, sound guys. Yes, you guys are networking because you understand routing your cables. You understand your cable progressions between this audio mixer to that audio mixer and this device and that device and that device. And let me tell you, there's some stuff out there that you guys will blow my mind on, because I'm like, wait a minute, I ain't never seen that before. That's cool as hell. But it is very apparent you guys need some basic IT.
Yeah, because I'm the guy, literally, if I'm running PTZ cams and I have the option of serial versus network, and I don't have to run 100 or 400 or 500 feet and all, I'm doing serial, and I'm going to run it, and I'm going to do it that way, and I know that we're solid. If I have to network, I'm going to make it happen. We're going to get it done. But, again, man, I'm very thankful for this. I did learn some things, and like I said, I took pictures of everything, so I'm going to go back and use that as a guideline to fall down the rabbit hole again. But if anybody has any information that'll make it, point me in the correct direction rather than I go one way and fork off 10, I would very much appreciate it, because then I can take some time out to learn that, because I know I'll be going down the correct direction. Thank you.
Looks like Nick, you got a question?
Yeah, I was just gonna say I have the same type of deal. I've done a lot of network for like just local area, connecting a lot of video equipment and things like that. But when it comes to the incorporating the internet, that's where we need more strength. Like, when it comes to gateway and things like that. So like on show site, it's just mostly linking lots of equipment together. For me, and not having to usually incorporate the internet into that.
Right. Yeah. A lot of our networks end up being closed off. Like, a lot of Dante networks are, if you're in a live production, you're not tapping into the infrastructure of the venue. You might be running your own cables, and it's pretty much closed network. So that does change it. Hey, Omar, it looks like you got a question.
Yeah, so just literally jumping off exactly what you just said right now. Is there a way, if I'm live streaming from a location, let's say at a hotel, right, and I'm trying to live stream out, is there a way that I can ping or do something Like if I know that, hey, I'm getting content, I'm streaming it, everything's fine on my end, it's not going out to the world. I know that the hotel's blocking me from like leaving the property. Is there a way I can do that on my end that I can say, hey, listen, I just pinged whatever, and like now I know like we're streaming. You guys are the ones blocking us. You need to change your thing. Because the problem
Yeah.
I run into before streaming was the main thing was that we would tell the hotels, hey, we're going to stream out to the world, blah, blah, blah. And they would block us because of whatever protocols or safeties they had within the hotel. And we had to like have this whole pre-production conversation. We're like, hey, we literally plugged in the hotel right now to stream out and we're not. And
Yeah.
we're going to be here in 2 days. So what's the solution here?
A really good utility, which you can either do it, you can find utilities. On the Mac, you have a app called Network Utilities. One of the functions in it is traceroute. So if you know what the name or IP address of your distribution server you're trying to go to is, you can just do traceroute to that, and it'll follow a series of hops. It'll say, okay, your computer's IP address, your gateway's IP address, your router's IP address, and if it dies at the hotel and never gets beyond their IP address range, then you know that's where the packet died and it didn't get out. If it makes it out all the way to the public internet or into your distribution server, but you're not getting content, then they're probably not your problem. You gotta go further and deeper.
But the trace route would tell me that, or at least it'd give me a rundown of where I'm going. So I
It would-
know.
It would
Hey,
follow your
I have-
attempts to hop to that destination and tell
Gotcha.
you whether you hopped all the way or whether you hit a wall partway along the path.
Got it. And that's a feature in Mac called traceroute, right?
If you look in Mac, there's an application called Network Utility. He says as he checks to make sure he's not screwing up the name. Yeah, Network Utility. And it gives you a lot of useful things like ping, traceroute, whois lookup.
Great. I was waiting for everybody to look down at their screens to start finding that. I think, did anybody else have a question or a comment? Andy Lipnick.
Yeah, first of all, Justin, thank you. A long time ago, I took the first level of certification for CNA for Cisco, and you basically covered that first class in this hour or so. So thank you for that, because it's a good refresher. And I kind of feel like what you did was talk about the entire war, and some of us need the battle.
Yeah.
but we need to know what the whole thing looks like. It's really useful. Along with that, I think that use cases for troubleshooting, we were just talking about like what do we need as production personnel to do our job, and I think that we need to know our own networking of our own gear, and if we're working on a large enough production, hopefully there's someone like you on board who's going to get us all to talk to one another properly. Often, and I've worked on them, I'm sure a lot of you have, there isn't that person. So we're going to each other trying to figure this stuff out.
Yeah.
So the troubleshooting aspects really help. And like, for example, real case scenario for me was I was given a Dante system where it was using link local and there was a failure point on one of the switches. It wasn't in triple lead mode. That's another conversation.
Yeah.
But the result of that was it took 30 to 45 seconds for the network to come back up. My understanding is if we had static IP addresses, and you had touched on this earlier, it would have connected a lot quicker than that. Those sorts of things and stories are, I think, for our community are really important. And I just wanted to hit that home there.
Oh, I agree. I mean, my goal tonight, I said to Ed, I forgot to say it, is, I kind of went into this protocol agnostic to just, because Ed and I talk about this, there's so much to do, we can't hammer it out in an hour in some chat. So yeah, this really does have to be, how's the network work? Some of the more advanced, if we do more advanced stuff there, but also more of the protocol specific and application specific stuff. Yeah. Just to answer your question, what happens in there in link local where it takes forever to come up? It's the DHCP servers again, because your clients all want DHCP, but it takes them 45 seconds to a minute before they give up and revert to link local, which is why you have this horrible downtimes.
So on Facebook, we had a follow-up question from David, or comment/question, where he says, surely everyone would have their own routers as opposed to using the venue routers, or is it an issue of having multiple router setups? So that's something where if we're bringing in one of those all-in-ones, what would we run into because the venue has its own router infrastructure with their IT?
The trip up point would be having the same subnet. As long as you're using distinct subnets, and my advice is pick something suitably random. I mean, when I assign them, there's some commonality, hey, my home network, the second octet is my street address, but if you're using 10, 126, 172, whatever, I'll bet against the venue having the same one as you do. And then most of the home all-in-ones or routers are set up by default to be DHCP clients on the internet side. So in that case, what should happen, as long as you don't have a duplicated address, when you plug into the venue's network, it'll give you a DHCP grant and the routing will just go up the chain appropriately. So as long as you don't hit a firewall block that you have to negotiate with them, you should be fine. And yeah, same thing. If everybody's running their own routers, as long as you're using different network ranges or don't have to talk to each other. Because one thing a lot of venues do is they block clients internally from talking to each other for security. So you may have to go to venue IT and either ask them to unlock that or bridge yourself behind your main show router and then pass it.
And so bringing in your own, like an all-in-one router, say you're doing that and you plug into the house network, introducing a second DHCP server, is that going to cause you any issues?
You are not introducing a second DHCP in that case, because their DHCP server is giving your box an address grant, but it's not passing beyond that. Your box is giving your devices their grants. So you don't have a second server because you're essentially two different networks divided at the router.
So then you would definitely want to make sure everything is on as far as your show equipment then is into your own router, as opposed to having something onto their network and your network.
Yes.
That's when you'll run into an issue. Great.
The consensus best practice when you talk to people about this for show productions, even in cases like my house gig where you have to deal with an enterprise IT department, is the general best advice is you should run your production stuff internally and have one connection point to the house network. So connect all your show stuff, and then there's just one link to whatever you have to get into or out of the house. If you have to use house IT in a corporate campus, it gets messier, but general rule of thumb, yeah, have all your stuff talk to your stuff and only one point of contact with the house network.
Copy that. Thank you. That makes sense. If anybody else,
so what I'm hearing about that is it's actually probably good practice if you are putting the venue or the show on yourself, like in Jason's case where he's using cameras and needs to make sure that they're going to connect fluidly through networking, would be to have your own router and add the device to you and have it communicate through your own router.
Yes, absolutely.
Okay.
Because you can, in terms of having to be the 192.168, if you pick a subnet that's fairly random and unique, the odds you're going to have a conflict are very low. And as long as your stuff's talking to its stuff, you don't have the problem. And it's also a troubleshooting thing. If your stuff is working with the house stuff and there's a back and forth with the house IT guy, this is your problem, this is my problem, you just unpull the one cord linking them and you find out real fast whose side the problem is on, and it makes solving it a lot easier.
So Jason, looks like you got something to say.
Yeah, so basically, like, just coming off of what Omar was saying about the hotels blocking you out, that's one of the reasons I always bring one of those mobile hotspots. That's one of the reasons that I've invested into it, is because, some of the sites, I mean, Friday we were supposed to be at Orlando Amphitheater. I mean, that got canceled, but we were supposed to be out there, and their line internet that they were supposed to have for us, dedicated for us to live stream, was about 600 feet away from where we actually were filming. So now we have to make it work. So how do we do that? So it's not the best, but it is the option to get a clean stream. You're going to get, now it's dedicated. Nobody else is working off of your Wi-Fi, if I'm correct, because it's my pack. It has my passwords on it. Nobody else can log into it. So I'm able to, use that to send my stream to the point that it needs to go, and I'm able to make it happen. So in the case of where, and I've been in that situation where a hotel, they gave it all to us, we're blocked out, it's a Sunday, their IT guy isn't there, they can't get a hold of him. What do I do? Well, he's at the beach hanging out or something. I still have a gig to do. So I just use that hotspot, and it works with the, especially with the Teradek Video Pro. I just boom, and we're good to go. And, I haven't, knock on wood, I haven't had it drop off yet, but I always bring that as a backup, because you never know when you're in that situation like Omar's talking about. And if it's a Sunday, you can't always guarantee that IT guy is going to be on call. If it's late night on Monday and you're still in a late night session and it has to be streamed, you never know. So that's what I do. I just drink as a backup. I have that, and I just, find a way to charge a little bit into each gig, so it kind of pays off.
Yeah, and it's, always have a plan C. If you don't have a backup to your backup, you don't have a plan. And that's certainly one way out. And one of the takeaways when we're talking best practice here is, in this world, house IT is part of the advanced process we all have to be thinking about. When you're calling the gig, you need the measurement, you need the drawing, you need the IT contact. You need to call them and go, hey, you got any firewall blocks? If I give you the MAC address of my router, can you set it up a guaranteed address and guarantee I can get through the firewall? I need this much bandwidth. Can you guarantee it? Because yeah, a lot of places may not have that guy, but it's part of our advance. And frankly, if the house doesn't have the brain and the knowledge and the manpower behind it, you're better off finding out a week out from the gig than at loading and fax. So yeah, it's certainly one of the takeaways is this is now something, we need to talk to the TD, we need to talk to the IT guy. It's part of our advance now.
Real quick, I just want to say for everybody out there, Facebook, thank you for tuning in. Thank you for being with us. We're about 10 to 11 minutes from wrapping up. If you want to get into your last minute questions, and go ahead and get them out there, we'll be more than happy to get them in and get them answered.
Excellent. So I actually got a question that came in from Adrian, who's not able to have his camera on at the moment. He said, should we have a firewall set up for a live show? Would that be necessary? So I'm assuming he means on your show network.
I really don't see much of a need for it on the show network. In fact, I think you get in trouble. Certainly you want to be firewalled facing the internet. Because a firewall is basically a router with added traffic rules. So it's saying, this is going from this network to this network, but traffic can't come in except in these circumstances. So yeah, you probably don't need to restrict that on your show, but definitely to the public internet.
Yeah, you wouldn't want somebody just being able to get into your network.
That's very bad.
From the outside. Omar, and then I think I saw Andrew's hand earlier, so.
Actually, I'll let Andrew go first. His hand was up, and then you can come back to me.
Copy that.
Well, I only was going to ask this. I wasn't really going to ask this unless we run out of questions, so you can decide whether you want to answer this or not. The dot local stuff, you touched on that a little bit, and I'd love to know a lot more about that. I know that when I use my Raspberry Pi, for example, it comes up as pi.local, and I know that my computer comes up as something.local. My printer comes up as something.local. Now, you were saying it's something to do with multicast, but is there a little bit more you can tell me about that?
Sure. There's two basic ways you can do domain name resolution, which is you can have a unicast server where your device queries it and says, hey, I'm looking for this name. Do you have an address for it? But that requires a dedicated server you can talk to. What happens in multicast DNS, aka MDNS, aka Apple's Bonjour, is when your device logs on the network and periodically it just goes, hey, I'm at 1044, 186, whatever, and my name is Justin's MacBook.local. Or yours says, hey, I'm Raspberry Pi 2.local. So in one case, there's a server that holds the repository, which is what's usually used to resolve normal domain names or regular domain names. And if you're doing multicast, then there is no repository. The devices are all just holding up their hands and saying, hey, I'm known as this. So that's what's happening with the .locals. That's all multicast where the device is sending out and go, hey, I answer to this name.
So the Mac is taking care of this? Like if I don't have a Mac product on my network, will this still happen?
Mac and mostly Unix type distros tend to be good about IDing as .local. Windows, not so much. But yeah, if you're doing multicast DNS, that's Apple's and the Unix implementation of it generally.
Okay, thank you.
Just so to touch on that a little bit, Andrew, your Raspberry Pi is running, what are you running on it exactly?
Well, at the moment, it's the Raspberry Pi OS.
The OS, yeah. So the OS is built on a Linux base, and the Linux base is actually a copy of the, and I hate to say it like this, and don't yell at me, guys, because a lot of you are going to be like, Linux is not Apple. Apple's software is Apple's OS is direct derivative of Linux. So when you use a Linux operating system, your local host is a Mac local host because it is a Mac essentially, is because it's identifying as a Mac in essence.
Different branches on the Unix tree.
Omar?
Yeah, sorry. So I was looking this up. So I got a text message came in. He wasn't able to comment online from Mike Smith. He was asking, and I know we kind of mentioned this real quick, and this may be a talk or a conversation for another talk down the road, but is there any easy way to monitor how much bandwidth we are using without digging into the router or the switchers?
Again, depends on the app. It will be most easily available on the switches and the routers. But again, application specific. You're running Dante controller. It'll tell you how much each device is using and how much unmanaged multicast you have overall. So the stock answer depends.
Right. So I think his question is directly towards monitoring what he's streaming out as a whole in his server, as in the whole network, actually, what everybody's, I guess, streaming up and down, not just individually from one computer, like what they're all doing as a whole.
You have to do it at the router or the switch because you have to be looking at a point where all the traffic's going through. So if you're looking at a single point, you're only seeing that. If you want to see the total use, then you have to be at the router or the switch to see the total use through the outside world interface.
Got it.
Hey, Justin, maybe while we're talking about that, what would be a way that someone could find that? How can they get into the router or the switch to see that information typically?
They should all have on a managed switch or the router, you'll have a management interface, and they're all different. Every manufacturer does it differently. But if you log into the web management interface, it should have, at least on any decent model, be able to look at a port or interface and show you how much traffic's going through it. Cisco will do it different from Linksys, will do it different from Ubiquiti, will do it but it should be in the management interface.
And usually,
and no, I'm not even going to say the letter CLI, Chris.
And that's usually if from like a browser, you would put in the a lot of
the
them
device's web address.
Right.
I mean, yes, some of them will resolve their own name, but usually it's the web address on the device. Sorry, Omar.
No, you're good. Andres made a point. What happens when you're doing all of it? NDI. I'm sorry. What was it? It was NDI. What is the other one that is out there? Dante, NDI, Dante, and video and internet. Like, what's the way to do all that? Is that just going to whatever's being sent out at that point, whatever router is being sent out?
Loaded question, because NDI, Dante, et cetera, are all designed to work on converged networks, which is to say you can run all of it on one network. The rabbit holes we didn't go down on things like quality of service or multicast flow management become a lot more critical at those levels, and you have to be a lot more involved in your management. If you're running just a network that's just Dante and its own gigabit network, you probably don't have to worry much. Same thing, your own NDI network, not much problem. You certainly can run them converged on one network, but at that point, you're into the switches and the routers and worrying a lot more aggressively about your traffic and flow management.
Right, because you would have two different, not protocols, two different services that want to have the top level of service. They want to be the at the top all the time. So how do you make both of them at the top all the time, which is makes the QoS a much...
Oh boy, did you just open the 301 question. Because yes, you can assign quality of services for different traffic levels. And the dodge to that is a lot of things like Dante or QLAN have 4 priorities, but a lot of switches will let you set 8. So you just kind of stagger them down. But yeah, Omar.
So sorry. I think I got one more question before we close out here. So we just got asked by, oh man, I'm going to mess this up.
Jerry.
Gary Pion.
Jerry. Yeah, I know Jerry.
Okay. So you got the name. So good thing you just skipped the whole thing. So Jerry Pion, the easiest way to get to Mac and PC to talk. That's literally the question.
Internet, Ethernet. It's, again, going way, way, way back to slide 1, it works its way down. At layer 1, it's both ones and zeros over the wire. So what are you trying to get to talk? Are you trying to serve a web page? Are you trying to share a file? There's, the network is the common denominator. It's just what information you're trying to share.
I don't know if we have enough time to dive into his question here. Maybe that was.
I'm mentally thinking of the other 4 hours of stuff I wish I'd been able to cover.
Andrew, looks like you have something else to add before we close out.
Yeah, very quickly. Is there a reasonably priced switch or router that gives you the ability to log into it and see bandwidth usage on all the different things that are coming into it? Is something I can put into my house, let's say, that doesn't cost me $10,000 that I could use to watch bandwidth?
I am a non-sponsored endorsement. I've become a big fan of Ubiquity, UI.com. They make a series called the Edge routers. They have the Edge Router 4, which is what I'm running by my left knee here, and what some really big TV trucks I do work in are running. It's a very capable box. If you go down to the bottom edge of the range, they have an Edge Router X, which is very basic and a great box to learn on, and it's like $60. So in terms of a much more powerful tool that gives you a lot more control and a lot more granularity, it's really hard to beat them for the price.
Okay, I have a bunch of Ubiquity stuff, and they're hundreds of dollars, so that doesn't bother me at all. I take the Ubiquity and I put WRT on it because I can't stand their interface, but they have a router that works that same way.
Yeah, the Edge routers and the Edge OS are very good.
Great, thank you.
Great. I think, sorry, Ori, there was something you wanted to touch on from about Henry's question earlier, right?
Right. So jumping back to what Henry had asked about syncing files across 4 computers on a network. I mean, in a lot of situations, we tend to use cloud solutions now. For my own use on my home servers that I have running for personal use, I I just started playing with this application a few weeks ago. It's been working really well for me. It's called Free File Sync. So as long as you're on the same network, even if it's a network that's closed to internet traffic, you should be able to run that on Windows machines if you're in the same work group. Mac's the same. It exists for Windows, Mac, and Linux. And you can basically schedule batch jobs. So you can set up your comparison from one directory to another, and it can compare things down to the file contents level and either clone or make backup copies or keep an updated backup. So you could run that on each of the remote machines and have them ping the whatever machine you're setting your files is up on, you're creating your new presentations on, and then the other machines should download that from them.
I mean, Omar Ed is going to kick us off at this point, but one other product to do a quick plug on is a product called Synergy Pro, which I love because it lets you share one mouse and keyboard across multiple computers. And while it's a little buggy, it also has a drag and drop where you can just drag a file from one computer to the other, and it does all the network.
Do not be
back-end
polite
work.
in that little buggy. Come on now.
Yeah.
Don't be polite with it. It can be, I don't know if anybody here has used it before on show, but I'm sure you've probably sat there and thrown the mouse a few times trying to get it to actually work because you're sitting
when
there
it
going,
works, it's
I'm
great,
moving
but
and it's not doing anything.
Yeah, it works great. And for a UI control, it's great. The file, I would not hang a show on it, but in theory it's there. But yeah, it needs a little love.
A lot of love.
So yeah, I mean, just my takeaway, I mean, there was a lot of stuff. We tried to dive into the what's behind the plug, but yeah, I think absolutely we could talk about doing a network thing. I think at some point we should have a security talk.
But huge. Yeah, definitely.
Because that freight train is coming at us fast.
Yeah. I just want to share David, who we answered a couple of his questions earlier. He said he had no idea what subnet was about, just used to ignore that. As long as it was the same as the devices I was using, I was usually good. All makes sense. Thumbs up. So great. David definitely got to gain a little more knowledge about subnet and why he shouldn't just ignore that.
Yeah.
So yeah, no, we are running up on time. We like to have a hard out because no one likes to break the hour. Well, everyone likes to break the hour if they're getting paid, but
yeah, you owe me OT at this point.
Yeah, exactly. So I want to thank our panel. Sorry, I'm doing multitasking here, but I want to thank all our panel. I want to thank Chris and Omar, our co-hosts, and everybody who joined us here for another week of AV Tech Talks. We're here every Monday night on Facebook from the AV Educate page. So if you go to the AV Educate page, like and then follow, you'll get the notifications of when we go live. Next week, we are covering vMix. So in the Facebook comments, I just dropped the link to the event page. So go like the event page. That way you'll get any updates we post in there. And then the week after that, the 31st, I'll be doing an audio talk.
Audio with Ed.
Yeah, that's gonna be fun. I'm in the same boat as Justin, where audio is such a vast topic. How do you narrow it down into bite-sized pieces? I think I've got it figured out, and there'll be some interactive demo stuff, which will be great. And my little guy wants to say goodnight to everybody, so that's a thing.
The real boss just showed up.
Yeah.
Everyone, I pooped on the fire.
Yeah. Look at them; they're clapping for you, bud.
Hey, that's an achievement.
Oh, that's awesome. That couldn't have been any better. I didn't tell him to say that, so that's great.
I was going to say, how much time did that take?
This just became YouTube gold.
Yes.
Oh, it did. Yeah, no, he's been super proud of himself. We've been super proud of him. 6 times he's gone poop in the potty this week, so we're happy about that. And I guess you guys can see how red I am right now. That's so funny. So thank you, everybody from Facebook. Thank you guys on the panel. We will see you here again next week. Omar, Chris, you got anything to say?
No. He closed it out perfectly.
He
I don't
said
want
it
to
all.
talk.
Yeah, that's
He said it all.
Yeah, you're only as strong as your weakest
Close it
cable,
out.
guys.
You're not gonna beat that.
No, we're not. So everybody have a good night, and we'll see you next week. Bye, Facebook.
Daddy,